Mathematica and the Raspberry Pi. Frequency modulation and Bessel's functions. We will write the basic FM equation for sinusoidal modulation, and then use the manipulate function to control the carrier frequency, and modulation index. We will also plot the Bessel's functions of the first kind for the first 4 terms. Finally, we'll plot the spectrum as the modulation index is varied. The FM equation. We'll specify the carrier frequency, the modulation frequency, and the modulation index. Plot the results. Add a plot label. Insert frame labels. Add the modulation signal to the plot. Add a plot legend. Add the manipulation function. Change the constants to variables. Add a frame label. Run it and make certain that the sliders work as expected. Now we'll plot the basic Bessel functions of the first kind. This can be interpreted as the amplitude of the carrier as a function of the modulation index. These additional plots represent the amplitude for the first 4 side frequencies as a function of modulation index. Add plot legends. Add grid lines. Add a plot label. Add frame labels. We're now going to plot the FM spectrum as a function of modulation index. We start by making a table of the Bessel functions. The negative values of n correspond to the lower sideband and the positive ones to the upper sideband. Since we verified that the table works, we can now plot the results. Fill the data points to the axis to make it resemble a spectrum. Add a plot label. Insert frame labels. Add a manipulate function. Make the modulation index the variable. Add a frame label. The FM spectrum is a function of modulation index using Bessel's functions.